Now, let's talk about the improper integral. But before we proceed, let us define what improper integral is. Improper integrals are definite integrals where one or both of the boundaries is at infinity, or where the integrand has a vertical asymptote in the interval of integration. As crazy as it may sound, we can actually calculate some improper integrals using some clever methods that involve limits. Okay, now here are some properties of improper integral. First is the upper limit. If integration of f of x dx from a to t exists for every number t greater than or equal to a, then integration of f of x dx from a to positive infinity is equal to the limit of integration of f of x dx where t approaches to positive infinity. Next is the lower limit. If integration of f of x dx from t to b exists for every number t is less than or equal to b, then integration of f of x dx from negative infinity to b is equal to the limit of integration of f of x dx from t to b where t approaches to negative infinity. The improper integrals such as integration of f of x dx from a to positive infinity and the integration of f of x dx from negative infinity to b are called convergent if the corresponding limits exist and divergent if the limit does not exist. Okay, now let's proceed to the example number 1. The integration of 1 over x from positive 1 to infinity. So it is an upper limit, right? So first, we need to integrate our function, which is the 1 over x. So integration of 1 over x is ln x. So now, equals to the limit of ln x from 1 to t, where t approaches to positive infinity. So let's distribute. So equals limit of ln t minus ln 1 from 1 to t, where t approaches to positive infinity. Equals limit of ln t minus limit of ln 1 where t approaches to positive infinity equals limit of ln t where t approaches to positive infinity. So, hindi ko na isinulat yung limit of ln 1 kasi ln 1 is equal to 0. So, limit of ln t where t approaches to positive infinity is infinity na lang ang magiging answer niya. So, i-substitute natin si e doon sa positive infinity. So, ln, so positive infinity. So, magiging answer is positive infinity, which is, again, if we get the answer of infinity, so divergent siya. And kapag whole number naman siya, is convergent siya. Okay? So, let's proceed to the example number 2 para mas maunawaan nyo ang concept ng upper limit. So, integration of 1 over x squared dx from 1 to positive infinity. So, again, hindi tayo makakapag ln x diyan kasi yung numerator natin is merong squared. So, ang magiging pwede lang natin gawin is itaas si x squared. So first, let's equate our equation to the limit of integration of 1 over x squared dx from 1 to t, where t approaches to positive infinity. Okay, now let's integrate our equation, which is 1 over x squared dx. So equals, tataas natin si x squared, which is magiging x raised to negative 2 dx. So let's integrate x raised to negative 2 plus 1 over negative 2 plus 1. So magiging answer niya is x raised to negative 1 over negative 1. So ibaba natin si x. So ang magiging final answer natin is negative 1 over x. So yun yung ating magiging bagong equation doon sa limit of integration of negative 1 rather over x from 1 to t, where t approaches to positive infinity. Okay, now let's write limit of negative 1 over x, which is yung nakuha natin kanina, from the integration of 1 over x squared from 1 to t, where t approaches to positive infinity, equals, okay, let's distribute limit of negative 1 over t minus, which is yung ating lower limit, negative 1 over 1 from 1 to t, where t approaches to positive infinity. Sorry, I forgot to put the limits. So equals limit of negative 1 over t plus 1. So magiging plus, positive na siya kasi negative times negative is positive, where t approaches to positive infinity. So equals negative infinity plus 1. So sinubstitute natin si t from positive infinity. So negative 1 over infinity is equal to 0. So bakit? Kasi habang lumalaki yung number ni infinity, nag-a-approach siya sa 0. So for example, negative 5 over infinity. So 0 pa rin siya. So 0 plus 1 is 1. So whole number siya. So convergent ang magiging sagot natin. Hindi katulad ni L and T. So when we substitute dt from infinity, so yung ln natin is mag-a-approach siya sa infinity. So again, if the corresponding limit exists, so convergent siya. And if the limit does not exist, so divergent siya. In our example number 2, convergent siya kasi nag-i-exist yung limit niya. So, hope you learned something from the concept of upper limit.